Let's today discuss this very interesting topic of source conversion. Very often in networks, what happens is we get current sources and we have voltage sources, but it becomes difficult for us to work with current sources. It becomes necessary for me to convert that current source. Under what condition can we convert a current source? Suppose I have a current source here of 2 amperes, and this current source has a resistance of maybe 4 ohms, and I want to convert this current source. The best way to convert this current source is 2 into 4. Ohm's law, I into R is equal to V. 2 amperes, 4 ohms will give me a potential of 8 volts. So if I want to convert a current source to a voltage source, the first thing I will do is I into R. 2 into 4 gives me 8 volts. How do I fix up the polarities? My current is moving in the upward direction. When current moves in the upward direction, upper end will be positive. If the current is moving in the downward direction, lower end will be positive. Whichever direction my current goes, that direction will be positive. So I get a positive 8 volts battery, positive negative 8 volts battery. In series with this 8 volts battery, I will re-put this 4 ohm resistance which was earlier connected in parallel. I will put this 4 ohm resistance in series with 8 ohms. This is how I actually convert my current source to voltage source. How do I convert from voltage source back to current source? Oh, that's a little bit of common sense. 8 is the potential drop, is the source, divided by 4, that will give me a current of 2 amperes. So here I get a current source of 2 amperes. And the same 4 ohm resistance, which was actually connected in series, will now be connected in parallel. Let's take a very simple example. Let's take a very simple example and understand how to use source conversion in actual numericals. Suppose I have a circuit of this kind. Let's have a look at the circuit now. I have to find the current in this 100 ohm resistance. The method to be used is source conversion. क्या करना चाहिए? I want to find the current in this 100 ohm resistance. Remember one thing, do not touch that 100 ohm resistance. कसम खा लो, मैं इस resistance को हाथ नहीं लगाऊंगा end तक. I will leave my 100 ohm resistance as it is. I will start solving from this side. अभी सोचो, how do I start? I can see the 60 volts battery and a 20 ohm resistance. This battery and this resistance are connected in series. I can convert this to a current source. To convert this to a current source, 60 upon 20. 60 upon 20 gives me 2 amperes. Now, 3 amperes. I get a current source of 3 amperes. The same 20 ohm resistance which was connected in series now comes in parallel. So here I have converted this part to a current source. Rest of the circuit remains as it is. So let me redraw the rest of the part of the circuit. This is 1 ampere. This is 30 ohms, 50 ohms, 40 volts, and 100 ohms. Now, what can we do here? What to do further? Look at this part of the circuit. I told you, 100 ohm resistance not to be touched. Look at this part of the circuit. I can see 3 amperes, 20 ohms, and this 1 ampere. They're connected in parallel. That means 3 amperes and 1 ampere source are directly connected in parallel with each other. They both are in the same direction. So I can add them. This gives me a current source of 4 amperes and a 20 ohm resistance in parallel with it. That is, this part has been taken care of. This part has been reduced to this. This remaining part of the circuit will be as it is. I will redraw it. 30 ohms, 50 ohms, 40 volts, 100 ohms. Now what to do? Now 4 and 20 in parallel with each other. This is a current source. 4 amperes current source and 20 ohms in parallel with each other. Can I get rid of them? Let me convert this to a voltage source. So 4 into 20 gives me a voltage source of 80 volts. 20 ohm resistance in series with it. That means this part of the circuit is now converted to a voltage source. This part of the circuit is converted to
आप बीच में एक पॉज ले लो तो इसको भी थोड़ा हाथ नीचे करने का मौका मिल जाएगा.
You tell me, खाली इशारा कर मेरे को.
हाँ ठीक है.
हाँ चलेगा. चलो स्टार्ट है वीडियो.
This current source is now converted to a voltage source here. That is, this part of the circuit is gone. This remaining part of the circuit will be as it is. I get this as a 30 ohm resistance, a 50 ohm resistance with a battery of 40 volts and a 100 ohm resistance. Now in this circuit I can see 20 and 30 are in series. So let me get rid of them. The only problem here is bloody circuit diagrams. Too many circuit diagrams to be drawn. There is no other option. We have to draw them. And a 100 ohm resistance. We can see such a big circuit is now reduced to just a 2-lobe circuit. We can go on further. 80 and 50. You can see they are connected in series. Can I get rid of them? Yes, we can. I can convert this 80 and 50 to a current source. This will give me a current source of 80 by 50. That is approximately 1.6 amperes with a 50 ohm resistance connected in parallel. Again, look at the circuit carefully. 40 and 50 series. Can I convert them as well to parallel circuit? Yes, we can. If I convert this to a current source, 40 upon 50 gives me a current source of 0.8 amperes and my 50 ohm resistance comes in parallel. And finally, my 100 ohm resistance comes back. So I get a circuit which is something like this. Yes, one question would have hit your head. How did I decide this current is moving in the upward direction? That's a little bit of common sense. This was positive into the battery. And since this is positive into the battery, when you're converting this voltage source to a current source, current has to move from where your positive side was originating. Now again in this circuit we can see 1.6 and 0.8 in parallel with each other. They both are in the same direction. That gives me one current source of the value 2.1 amperes. 50 and 50 also in parallel with each other. So that gives me one resistance of 25 ohms. And of course, 100 ohm resistance remains as it is. At this point of time, we can reconvert this voltage source, this current source to a voltage source, or we can straight away apply current divider rule, which says take the main current 2.1 multiplied by the opposite resistance 25 upon 100 plus 25. That is 2.1 into 25 upon 125, and this gives you an answer of 0.48 amperes. This is how we use source conversion and get my final current in a particular resistance. Not to forget, first rule, the resistance where current is to be found, you should not touch it. If you look at my entire solution, my 100 ohm resistance, where I had to find the current in, I have not touched it. I have left it till my last step. When I'm doing source conversion, either convert voltage source or current source as per your convenience. Don't look at what we want. Okay. Follow your own simple method of source conversion. Try to be technically correct. That's source conversion. So keep doing source conversion. Enjoy doing networks. Thank you.